We are in 9.1, quadratic graphs and their properties. So, talked about these yesterday a little bit. We're still going to be comparing these to the original parent function. Need notes? Anybody else have notes? So we did the lesson yesterday. All right. So again, just one time this time, I'm going to graph the parent function. Okay, the parent function is already here. The parent function is y equals x squared. So they took, the creator of the worksheet, they took the -2 and put it in. Now that's -2 times -2 became positive 4. So if we graph that on here, -2 up 4, we get a dot right there. When we put in 2, a positive 2 squared would also get us 4. And that shouldn't be a surprise because what we talked about yesterday, we are going to graph what's called a parabola. A parabola is a shape that looks kind of like a U, but it's a smooth curve. And we're going to graph this parabola. And the parabola has symmetry. Symmetry means we can draw a line down the middle. And these 2 points that we graph, when we fold them over the middle line, they should match up. So that shouldn't be a surprise that those 2 are the same. Now notice, I'm not doing this over here yet. I'm not doing the column over on the right. We're going to do that next. We're going to graph the original function first. Now, if I put in a -1, a -1 squared got us 1. So -1 up 1. When we put in a positive 1, shouldn't be a surprise. We get the same thing, positive 1 up 1. The 2 points are the mirror image of each other if we fold them over. Then the last point, if I put in a 0 in here, 0 squared is 0, and that gets us this graph that we call a parabola, and it's the most basic graph. We could graph this every time. We only have 4 graphs in the lesson today, and we're not going to graph all of them, but we're going to graph one. So remember what we remember from yesterday, that's the parent function. That's the original. Okay, now this next one says y equals x squared plus 2. Okay, so I'm going to take this equation and I'm going to use our calculator. Maybe that's not our calculator. And I'm going to put in -2 squared, but then the equation says add 2. So it's x squared plus 2. The -2 squared will still be 4. And when I add 2, I should get what? Okay. If I put 2 squared, that should be 4. And if I add 2, that should be 6 as well. So those 2 still get us the same thing. Shouldn't be a surprise. When I put this one in, this one's 6 and this one's 6. So now at -2, instead of up 4, it slides it up 2 more squares to 6. This one slides it up 2 more squares to 6 as well. Okay, when we put in the 1, I'll start actually with the -1. -1 squared would be 1. When we add 2, we get 3. When I put in a positive 1, that also gets us 3. What's interesting is it's moved it up how many squares compared to this? 2, which kind of makes sense. Oh, this, it moved it up 2. So what do you think we're going to get when we get 0, when we put that in there? 2. It'd be up 2, right? We'll see. Put in 0. Yep, I get 2. So that dot should be here. These dots, 1, 3, -1, 3. Now when we graph this one, mine's in green, it's a little easier to see. All we see is my graph has been moved up how many for every point? 2. And that's what this 2 does. Our vertex then, talked about this yesterday, our vertex is the turning point. It's this particular point here. Our vertex is 0, 2. The vertex on this original graph was 0, 0, but that's not the one we want. We want the new graph, 0, 2. So that's this dot. Our axis of symmetry always matches the x. So x equals 0. Now again, what is the axis of symmetry? The axis of symmetry is this line going at x equals 0. A lot of times people draw it on there as a dotted line or dashed line, and it's where we could fold the thing over and all the points would match up at x equals 0. The domain, I could put any number I want into there, so we say the domain is all real numbers. And the range, now this is a little different than yesterday. Yesterday the range was always y is greater than 0 or y is less than 0, but it's not today because the green graph that I have, it doesn't go lower than how low? 2. Good answer, 2. So y is greater than or equal to 2 because that's the lowest y value we have when we put it in for the green equation that I have on there. Okay. Now, we're going to put this in and see what we get. When we put these in, we got the same numbers, 4, 1, 0, 1, 4. This equation asks us to do what this time? Subtract 3. So what do you suppose we get here? For the first one, when we put in -2. 1. So when we put in 2, we should also get 1. So I'm going to start by graphing that. I'm going to go to -2, up 1, +2, up 1. Now, when I put in -1, we'll try this one. -1 squared would be 1. -3 is -2. So when we put in +1, we also get -2. So 1 negative down 2. 1 positive down 2. Now usually when we graph these, we're going to see 5 points, and you'll see the parabola. Hopefully you can already see where the parabola is going to come in there. What value do you suppose we get here at 0 when we subtract 3? -3. So at 0, we're at -3. Now that one already gives us the vertex. When we put in 0, we got -3. That is the turning point. And remember, this is a smooth curve. Yesterday we talked about it. Some students graph it and they kind of make it really V-like. That's not what you want. You want it to be very smooth, not jagged in terms of your drawing. Okay, it's supposed to be a smooth curve as best as you can. The axis of symmetry always matches x, so x equals 0. If we were to draw a middle line, it would be the fold line here. Our domain is all real numbers. Our range, it opens up, so y is greater or less? Still greater because it's going up, but greater than what? What's the lowest value this time? -3. Okay, now what we've seen is what happens if we add a value, subtract a value. I'm going to make a comment on this. Down here it talks about an analysis. So, oh, it won't let me. There we go. So, adding shifts the graph up. In the case of our graph, it went up 2 on the first one. But subtracting shifts the graph out. All right, next one. Now this is going to be different. Notice how on these, the x squared was alone and there were no parentheses, and that plus 2 was after. Then minus 3 is after. Here, there's a minus 1, but it's in the parentheses. This is going to affect this much differently. So when we do this one, we're going to take this one. We had the 4, we had the 1, we had the 0, we had the 1, we had the 4. The normal graph would still be where it is. We want to see what happens to this one. You know, how does it move? Does it move up 2? Does it move down 2? That's the idea. We just learned that we can shift it up 2 by adding 2. We can shift it down 3 by subtracting 3. But now what do we do if we put a minus 1 in here like we have? So we have a minus 2, and we're going to put it into this equation. Minus 2, subtract 1. That's x minus 1 squared. That gets us 9. Now, the way it's always worked for us in the past is when we put in the other one, the 2, it got us the same thing. But here's the problem. Negative 2 minus 1 is negative 3 squared is 9. What's 2 minus 1? 1 squared will be, 1 times 1 will be 1. It didn't get us the same thing. Okay, so something else is going on, something new is going on when we put this one in. Those two aren't the same. Let's try the negative 1. Instead of negative 2, I'm going to put in negative 1. Negative 1, subtract another one is negative 2. Squared will be positive 4. We still haven't gotten any of the same numbers yet. Let's try putting in the 1. 1 minus 1 is 0. Squared is 0. Huh. None of those numbers are the same. Let's try the 0. 0 minus 1 is Negative 1 squared is 1. Aha! Now look, notice these two are the same. So 0, 1 is what we got when we put in 0. And when we put in 2, we got 2, 1. And then 1, 0 was here. Ah, there's our parabola. Can you see it with those three? This one, when we put in negative 1, it got us 4. So over here, if we put in 3, 3 probably gets us 4. We can try it just to see. If we put in a 3, 3 minus 1 is 2. Oh, that gets us 4. So now we found where it works, where we get the parabola. You don't have to graph all the points. What you're trying to do is find what it is. But what really happened to this graph, it moved the graph 1 to the what? Look at, this is the original, 1 to the right. Now it seems opposite, but look in here. When you're in parentheses, it's going to do something kind of backwards to what you think. This says subtract 1. Well, if I subtract 1, I would think that moves it to the left. But when you're in parentheses, it does the opposite. It moves it 1 to the right with the subtract. Okay, so what do you think adding 1 will do? Ah, good instinct. Move 1 to the left. Okay, but let's go down here and do the vertex. So the vertex, in this case, was here. It's at 1, 0. So the new axis of symmetry is x equals 1. Because we would draw the line down at x is 1. The domain, all reals. The range, y is greater than or equal to what? How low does it get? 0. Okay, so how did that one? How did that one work? Shifted the whole graph 1 to the right. We see that if we compare it to the original graph, it moved it 1 to the right. So this one, we're taking a guess that x plus 1 will shift 1 to the left, correct? We think it'll be the opposite, so let's see if we're correct. So now we're going to put in negative 2 into the x plus 1 equation. Clean up our sheet a little bit here. Negative 2, and we add 1. That gets us 1. Negative 2 plus 1 would be negative 1 squared is 1. Now I'm just going to go in order on here. I'm going to put in negative 1 next. Negative 1 plus 1 is 0. Squared is 0. I'll put in 0. Plus 1 is 1. Squared is 1. I put in negative 0. That really didn't matter, though. 1 plus 1 is 2. Squared is 4. 2 plus 1 is 3. Squared is 9. So we have 1, 0, 1. Notice which two match. When we put in negative 2 and 0, those matched. Yeah. 1, 0, 1, 4, 9. It flipped the thing. Well, let's see what that means. Negative 2, 1. So we go negative 2 up 1. Negative 1 up 0. 0 up 1. 1 up 4. 2 up 9. Okay. Did it take the graph and did it move it 1 to the left like we thought? Okay. So we confirmed that. Our vertex is now -1, 0. So what's our axis of symmetry? X equals what? -1. If we drew a line up the -1 line, we would find that. Our range is all reals, and our domain is all reals, and our range is y is greater than or equal to 0.